So hello all, I welcome you all in today's video topic that is multicast. I, Professor Rahul Diwate, Assistant Professor in Department of Computer Engineering, AISSMS IoT Institute. So what is multicast? So multicast is a group of communication where a data transmission is addressed to the group of destination computers simultaneously. And multicast that can be done with one-to-many communication or many-to-many communication or distribution. So in multicast should not be confused with the physical layer or point to multi-point communication. So the group communication may be either a application layer multicast or the network assisted multicast where the latter marks is possible for source to efficiently send to the group in a single transmission. So there are different types of multicast. So that we call it as a local order multicast, then casual order multicast, and the total order multicast. So we will look one by one. So the local order multicast, in local order multicast, if a process multicast two messages in order M1 and M2, and then every correct process in the group must deliver the M1 before M2. So it means if we created one sequence for transmitting our message from one place or one system to another system, and that order must be in form of M1 and M2. So it means if the one M1 message is get successfully transmitted, then only the M2 message will be get transmitted. So there are many applications of local order multicast. That is, one is the implementation of DSM, a distributed shared memory, where the primary copy of each variable is maintained, and by an exclusive process, all the other processes are cache copied of it. Whenever the primary copy is get updated, the owner of the primary copy multicast the update to the holder of the cache copy, and these copies are updated in the same order. And the other application that may include the video distribution and the software distribution. Second is a casual order multicast. So let us consider M1 and M2 are two messages and be a pair of message in a group. So such that if we send M1 message, then send M2 message. So then casual order multicast requires that every process in the system that must be deliver M1 before M2, and the local order multicast trivially satisfy this. So casual order multicast modifies it by imposing delivery orders amongst the casually ordered message from the distinct sender to. So we take one simple example where a group of students that scattered across the large campus are preparing for an upcoming quiz through a shared bulletin board. So someone comes up with a question and throws it into the entire group, and whoever knows the answer multicast it to the entire group. So the delivery of that question is of each student must happens before the delivery of corresponding answer. Since these are the casual related, it can be awkward, and we can say the violation of the rule of casual order multicast if some student receive the answer first and then corresponding the question. So this is a your casual order multicast. The third one is the total order multicast. In total order atomic multicast, so every member of the group is required to deliver all the messages sent within the group in identical order. So it implies that if every process I maintains a queue that initially the empty and to which the message is appended as soon as it is delivered, then eventually for any two distinct processes I and j, say the q dot I equals to q dot j. So it means whenever you transmit the message in a same identical order, so how many messages that you are sending through the sender side, it must be received that amount of message at the receiver side. So please, the one thing is that in order in which the message are delivered has no connection with the real time and in which this message were sent out. So we will look one simple example for that, how we are going to implement this total order multicast. So the first method is the basic multicast using sequencer. So first we define one sequencer. As you can see here in graph, there is highlighted as in red will be your sequencer and the remaining are your nodes. So it defines the sequence at the integer whether it is the initially 0. So they have to perform do when they receive the message, it will must multicast that message and the sequencer. Then the sequencer will get updated by 1. Then the sequencer is equals to the sequencer plus 1. Then it delivers the message and so on. So that's it for this video. We will meet in next video. Thank you.